Hello, it's another day and another ECM to bench test. So today we're going to be working on a Paccar out of an MX13. That would be, for example, a Peterbilt. This ECM is manufactured by Delphi, and it is three connectors. It has three connectors: a gray, which is connector A, a black, which is connector B. These are 62-pin connectors, and then a 92-pin connector, connector C. So the first thing we're going to do is we're going to hook this up to our breakout box that is connected to a DPA5. All right. Then we're going to hook ground, and then we will hook up power, but we won't do that just yet. So we're going to bring up the schematic or the pinout. So here I have pins 58 and 61, which are these two pins here for the coolant temperature sensor. I looked it up on the schematics, and that's where we need to go. So that would be on connector B over here, and we're going to hook up a jumper to that, and we'll do that with the power off. So the first thing we're going to do is we'll fire up the scope here. All right. Now, as you can see, that's pin 61, and that's pin 58. These pins are smaller, so we're going to use different breakout pins than we normally use in other videos. We use a small set of pins, jumpers. We're going to use a larger connector on the jumper to accommodate these larger pins here. So let's grab our jumper wherever I put it. All right, here it is. And you see this has larger pins than what we're normally using. And it's just hooked to a wire. So the power's off. We're going to hook to pin 61 and 58. All right. So check the scope. 51, 68. Then we're going to hook a jumper wire here. And a jumper wire here. Then we'll grab a thermistor. This is a 2K thermistor. So at normal room temperature, I forget exactly what temperature they're measured at. It's 2000 ohms, and that's why they're called a 2K thermistor. As the temperature increases or decreases, the resistance on this increases or decreases. So this is going to mimic our coolant temperature sensor. It's exactly the same thing that's in a coolant temperature sensor, except it's surrounded in a big housing with a thread on it. So let's go in here and we'll hook this up like that. There we go. I'll stop the recording. All right. Now the rest, we got to hook up the power and then go to the software. So a little bit of a spark there, and we've got 0.88 amps. It's not excessive. That's about what I expect. Okay, so let's go to the computer. All right, so here we are at the computer, and we're going to be using PFD-Tool. It's tool number, version number 1.3.35.98. And we're selected a DPA5 Pro, which is what we're using, and we're connecting to a Paccar. So in here, we would select Paccar. The variables that are down in this list here are J1939. We would select them through the Select Paccar Parameters. These are J1939 parameters. They're just in the Paccar list for convenience, and also we will probably be adding some proprietary PIDs here in the future. Now, this is the same thing as the other selections and the other engines. You check the box on the left to list it in the list. For example, parking brake switch, we're going to get rid of that. We don't need it. And you click the pin on the right if you want to measure the voltage or if you want to chart that particular parameter. So the pin on the right equals charted. So we'll save the change. You'll see the list shrunk by 1. And usually after I make a change on there, I like to exit out and start it again, but that's up to you. So now let's connect. There we go. And you'll see we're getting 29 degrees Celsius on the engine coolant temperature sensor, which is about what I expected. All right. So let's go over and check. Give it a little bit of a pinch with the fingers. It should make the temperature increase. Okay. And then let go. The temperature should go right back down pretty quickly. There's no housing or anything to warm up. There it goes. Now you'll see that the fault codes are lit up here like a Christmas tree. That's because the ECM, again, is not connected to a vehicle. So everything is an open circuit. And if I view the DTCs, you'll see a lot of them here are open circuit. Under range, over range, voltage too low. Now, occasionally you'll see one in here that may show up as no description in the database. So let's take this one, for example, 3421. There's no description in the database. It is a P code, what we call a P code. So it's a worldwide harmonized OBD2. And what we're going to do in this case is we can look this code up by using TechRepo. Now, TechRepo is a program that we provide for free. It's a repository for your software manuals for PDFs. It keeps everything nice and organized, and it's perfect in this case. So we bring that up. And we're going to go to Paccar right here. And that code that we're looking for is a 3421. So we go to Diagnostic Codes, 34. So it'd be in this group here. You open that. And P3421 right there. Click on it. It's engine brake solenoid valve cylinder 3, current too low or open circuit, again, to be expected. It's on connector A, which would be the connector that has it's the gray connector, and it would be pin 24. This is where the valve is located, and these are the wiring diagrams for it. And then we get into the harness connections, how to measure them, what measurements you should be expecting, plus or minus 36.5 ohms on pins 5 and 11. And you just follow these troubleshooting steps and you'll fix it. There's no way you can go wrong. It'll tell you to either repair the wire or replace the sensor or something of that nature. We've already tested the ECM for the coolant temperature sensor, so we know that the ECM coolant temperature circuit is good. And if we were to look in here, we could find the coolant temperature circuit and do a diagnostic on it as well. Now, keep in mind that since we've repaired that sensor, it's not going to show up in this list as an active DTC. We've cleared the list previously and have not run the ECM without, I don't think anyway, without the sensor in or disconnected. So I don't see a SPN. Oh, yeah, here it is here. So it is in here, SPN 110. It's over range. And now if we shut the computer off and start it up again, this will be inactive. And we can clear that by going in here and selecting clear code, delete all DTCs. And we can print a DTC report before we do that, so we have a record of it. So that's pretty much everything to go through on this. It's fairly simple. We're going to be adding more tests right now. The only test we have is a DPF regen test. I can't run through a regen test right now because, of course, we're not connected to an actual engine, so it'll fail. I can give you a show here. So it says to follow the recommended safety precautions. Please make sure your parking brake is applied, accelerator is not depressed, the park brake pedal is not pressed, and the gear shift is in park or neutral, depending if it's on automatic or standard. You hit OK. And I've got a regen error that says the engine must be running. Well, of course, we can't run the engine because there is no engine. So it'll back out of this test. So that's everything for Paccar. I hope you've enjoyed it. Hit like and subscribe. It helps the channel. It helps promote the videos to people who may be looking for a solution and don't know where to turn. We're always open to suggestions. And if you have any questions or comments, we'd like to see them. Be friendly, be nice. And you can email us, or you can go on our website and leave a message. You can go in and open a support ticket if you happen to be a customer, or if you have a question about the software, you can go ahead and do that as well. And remember, this is one and done. You pay for it once. That's it. We don't nickel and dime you. We're not going to charge you for each engine that we enable. We're not going to charge you for every feature that we enable. It's all the same. It's all included. And as we do upgrades, you get them for free. And if you have any questions and need support, you get it for free as well, for life. Okay? So thank you, and catch you on the next one.